Every computation an artificial intelligence performs is a consistent cycle of structuring and transforming data through a specific set of mathematical rules. By the end of this video, you will write exactly 5 lines of R code that simulate the core computational engine driving modern AI. You do not need an advanced math degree to do this. All you need is a keyboard and a web browser open to an online R compiler. By running these simple commands yourself, you will step past the typical abstractions of AI and see exactly how machines process information. Computers cannot process chaotic, real-world data directly. Before any learning can happen, information must be organized into rigid mathematical shapes. Let's create the simplest shape. Go to your console and type v equals c, 10, 20, 30 to create a one-dimensional list of numbers. Looking at this graphic, this one-dimensional structure is a vector holding isolated data points. Now step up the complexity. Type m equals matrix to generate a two-dimensional grid. Shifting right, this two-dimensional shape is a matrix. Typing dim of m reveals its row-by-column structure. Translating real-world concepts into these strictly formatted vectors and matrices is the mandatory first step that makes all subsequent AI computation possible. Once data is structured into these grids, the system has to combine them to find patterns. We start with basic element-wise multiplication. In your console, define 2 identical 2x2 matrices. Call them M1 and M2. Then multiply them using the standard asterisk symbol. This panel shows exactly what your console just did. Position 1 simply multiplied by position 1. Position 2 by position 2, and so on. This scales the existing numbers, but it fails to create any new relationships between the data points. To actually connect these data points, we need matrix multiplication. This is the heavy lifting tool of machine learning, and it requires a specialized command. Go back to your console and multiply those exact same matrices again using the %* operator. Looking at the right side of our diagram, a mechanical shift occurred. Entire rows from the first matrix interacted with entire columns from the second, generating entirely new values. Standard multiplication merely adjusts existing data. Matrix multiplication transforms it, providing the specific mathematical mechanism an AI uses to discover patterns. Now that you have the basic operations down, we are going to build a miniature working AI prediction loop using these linear algebra principles. Step 1. Type out a new matrix and name it input. This represents raw data coming into our model from the outside world. Step 2. Create a second matrix and name it weights. This grid is the mathematical representation of the AI's learned memory and historical patterns. Step 3. Execute the transformation. Multiply your input by your weights using that %* operator. This graphic maps the flow from the green input through the blue weights to the final green output generated in your console. Those new numbers are the AI's prediction. This interaction, using a matrix of learned weights to transform raw input into a new output, is the basic computational loop used by most machine learning models. Look at your completed R console. You have successfully executed a raw numerical transformation entirely from scratch. When you interact with massive generative models like ChatGPT, they rely on this exact same matrix multiplication operation. They simply repeat it millions of times across much larger tables of numbers. Go back into your code, change the numbers inside your input matrix, and rerun the script. You will watch the simulated AI's prediction shift in real time as the inputs change. Running these simple operations provides a direct view into the mathematical logic that modern software uses to process data. By changing the numbers in your script, you can see exactly how the final output reacts to every individual variable.